The concept of remainder theorem is if a polynomial p of x whose degree is greater than or equal to 1 is divided by another linear polynomial x minus a where a is a real number, then we get a remainder as p of a. This theorem is used to find the remainder while dividing two polynomials. We can also write p of x as x minus a into q of x plus p of a, where q of x is the quotient and the remainder is p of a. What if the remainder is 0? Then we can get a new theorem, which is the factor theorem. That is, if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of p of x if p of a equal to 0 and vice versa. That is, p of a equal to 0 if x minus a is a factor of p of x. Here we can prove this by using the remainder theorem. That is, p of x equals x minus a into q of x plus p of a. The first one is, if p of a equal to 0, then p of x equals x minus a into q of x, which shows that x minus a is a factor of p of x. Second is, since x minus a is a factor of p of x, then p of x equals x minus a into g of x for some polynomial g of x. So, p of a equals a minus a into g of a, which is equal to 0. Let's work it out on this problem. Examine whether x plus 1 is a factor of x square plus 3x plus 2. The 0 of x plus 1 is minus 1 and let p of x equals x square plus 3x plus 2. Then calculating p of minus 1, we get it as 0. So by factor theorem, x plus 1 is a factor of x square plus 3x plus 2. Let's cross check this by dividing p of x by x plus 1. So by long division method, we got the remainder as 0. Hence x plus 1 is a factor of x square plus 3x plus 2. Also we can write p of x as x plus 1 into x plus 2. So we can say that x plus 1 and x plus 2 are factors of x square plus 3x plus 2. This is the factorized form which can be formed by the process of factorization. Consider a quadratic polynomial ax square plus bx plus c where a not equal to 0, a, b and c are constants. Now this polynomial can be factorized by splitting the middle term method. Let the factors be px plus q and rx plus s. By multiplying them, we get prx square plus psx plus qrx plus qs. By taking x common, we get prx square plus ps plus qr into x plus qs, which is equal to ax square plus bx plus c. Comparing the coefficients, we get a equals pr, b equals ps plus qr and c equals qs. So we can conclude that the middle term b is the sum of two numbers ps and qr, and ac is the product of those two numbers. That is, ac, which is equal to pr into qs, can be written as ps into qr. Now let's see an example. Factorize the polynomial 6x square plus 17x plus 5 by splitting the middle term. Let 6x square plus 17x plus 5 equals ax square plus bx plus c. Then a equals 6, b equals 17 and c equals 5. For splitting the middle term, let the two numbers be p and q such that b equals p plus q and ac equals pq. That is, 17 equals p plus q and 6 into 5 equals 30 equals pq. Now we need to find the factors of pairs of pq, that is 30. They are 1 and 30, 2 and 15, 3 and 10 and 5 and 6. Now we need to add any of these pairs to get B, which is equal to 17. Here 2 plus 15 is 17, which is equal to B. So we can choose the two split numbers as 2 and 15. So the polynomial 6x square plus 17x plus 5 can be written as 6x square plus 2 plus 15 into x plus 5, which is equal to 6x square plus 2x plus 15x plus 5. Now we take common value from the first two terms and the last two terms. We get 2x into 3x plus 1 plus 5 into 3x plus 1. Taking 3x plus 1 common, we get 3x plus 1 into 2x plus 5, which is the factorized form of 6x square plus 17x plus 5. Now let's go to the next level of factorization. Let's factorize a cubic polynomial, that is x cube plus 13x square plus 32x plus 20. Let p of x equals x cube plus 13x square plus 32x plus 20. Now we find the factors of 20. They are plus or minus 1, 2, 4, 5, 10 and 20. By trial method, we find p of the factors of 20 to get 0. We find that p of 1 equals 66. Then p of minus 1 is 0. So x plus 1 is a factor of p of x. Dividing p of x by x plus 1, we get the quotient as x square plus 12x plus 20. So p of x equals x plus 1 into x square plus 12x plus 20. Now we can factorize x square plus 12x plus 20 by splitting the middle term. We get p of x equals x plus 1 into x plus 10 into x plus 2, hence factorized. So we can conclude that we can factorize quadratic polynomials by splitting the middle term and cubic polynomials by trial method of finding one of the factors and then performing long division and splitting the middle term method. Also, by factor theorem, we can find out whether a given linear polynomial x minus a is a factor of a polynomial p of x.